Hello students, we will start with the fifth module. So topic name is polar plot. So we will solve the numericals on polar plot. The problem definition goes in this way. Draw the polar plot for a given unity feedback system whose gain g of s is equal to 1 by s, 1 plus s, 1 plus 2s, and also find gain margin, phase margin, omega gc and omega pc. So omega gc means gain crossover frequency, omega pc means phase crossover frequency. For the given numerical, here unity feedback they have mentioned, means h of s will be what? 1. Okay, so we will go through the solution how exactly that flow. So in the first step, to plot the polar plot, so put s equal to j omega in the given g of s, right? Substitute s equal to j omega in the given equation, that is g of s will become what? G of j omega, right? 1 divided by, here s is there, s is replaced by what? J omega, 1 plus, again j omega here, plus 1 plus 2 as it is in the place of s, j omega, right? So we call this one as equation number 1, right? Next, you need to find a magnitude and phase from this graph, right? So that is our magnitude is given as g of j omega is equal to 1 divided by, how to find the magnitude of this one? So this j omega can be written as 0 plus j omega, right? What is the real part here? 0. What is the imaginary part? Omega. How to find the magnitude of this one? Magnitude of j omega is equal to under root real part square. So that is 0 square plus what is the imaginary part here? Omega. So therefore omega square. This results in omega square under root. So this will be what? Omega. This is what we have written here. So magnitude of j omega will be what? Omega. Right? Similarly, you need to find a magnitude of this term also, that is 1 plus j omega. How to find this one again? So under root real part square. What is the real part here? 1 square plus what is the imaginary part here? Omega. So omega square. So that results in what? Under root 1 plus omega square. That's what we have written here, right? Similarly, we need to find the magnitude of this term also, that is 1 plus j2 omega. Real part is here 1 square is what? 1 plus. What is the imaginary part here? 2 omega. Its square will be what? 4 omega square. So totally, so this can be written as magnitude of will be what? 1 by omega under root 1 plus omega square under root 1 plus 4 omega square. Call this one as equation number 2. Right. Similarly, we need to find phase also. Phase for the equation number 1. So how to find the phase of an equation or phase of any term? So let us put up here. So how to find the phase of this one? So we need a phase angle of this will be what? This can be written as 0 plus j omega. So we know how to find the angle, that is phase will be what? Tan inverse of imaginary part by real part. What is the imaginary part here? Omega, right? So tan inverse of omega. What is the real part here? 0. Omega by 0 means anything by 0 will be what? Infinity. Tan inverse of infinity will be what? 90 degree. Since this term is in the denominator, if I take in numerator, this will become what? Minus 90 degree. Similarly, what is the angle of this one? Phase of this one? Tan inverse of imaginary part by real part, omega by 1, that is tan inverse of omega. Since it is in denominator, if I take in the numerator, so that will get what? Minus sign, right? Similarly, the angle of this term, that is 1 plus j2 omega. What is the angle of this one? Tan inverse of imaginary part by real part, that is tan inverse of 2 omega by 1. Since it is in again in the denominator, so it will get to what? Minus sign if I take in the numerator, right? So this is what the writing the equation for given g of s in the s domain with a magnitude and phase. Now, so from these two equations, from equation number 2 and 3, so we can make a tabulation here. So that's a tabulation consists of 3 columns. omega, which is in terms of radians per second. So then magnitude, that is g of j omega. Then third column is phi, that is angle of g of j omega. It is in terms of degrees, right? So need to vary the value of omega starting from 0 up to what? Infinity. So you should get the magnitude also, corresponding angle also. Now see here, by using equation number 2. So if I substitute omega as 0 here, so this will be 0, this will be here 0, 0, 1 by 0. So that results in what? Infinity. So for this omega equal to 0, so magnitude will be what? Infinity. Similarly, to find the angle, you substitute omega here as 0 here. So it's a minus 90 degree, right? Tan inverse of will be 0 will be what? 0 degree. Tan inverse of again 0 will be 0. So overall will be what? Minus 90 degree. So therefore, for omega equal to 0, so angle will be what? Minus 90 degree. So you should go on vary the value of omega till what? Infinite, and get the values of magnitude as well as what? Phase. So main thing here in the tabulation is, for what value of omega, we are getting the magnitude 1. That is very important. So that's why I mentioned here. Similarly, for what value of omega, the phase angle will be minus 180 degree. So these two row values are very important to find these parameters. What are these? Gain margin, phase margin, gain crossover frequency, and phase crossover frequency. In the introductory class, I have discussed for what value of omega. So our polar plot having the magnitude 1, this corresponding frequency is called as what? Omega Gc. So that is gain crossover frequency in terms of radians per second. And also I have mentioned for what value of omega, so our polar plots cuts minus 180 degree line is called as omega Pc. Means in this tabulation we have got the two values, that is omega Gc as well as omega Pc. So in terms of what? Radians per second, right? Now we need to find gain margin and phase margin also. For that reason we need to plot a graph of this from this using tabulation values. Now see here how exactly. So we need to plot the graph that we are going to see now. Now start drawing the graph, assuming, so this is the graph, it's a rough graph I am drawing here. This is the real part of g of s and h of s, this is the imaginary part, right? So I'll take one unity circle here. This is called unity circle, right? In this unity circle, I need to plot these values. Means I need to consider omega equal to 0. I need to plot this magnitude as well as what? Phase. Now I will consider omega equal to 0. What is the magnitude of this one? I need to check. Magnitude is what? Infinity. Means that corresponding angle is how much? Minus 90 degree. So this is the 0 degree line. This is 0 degree line. So if I consider this one, this will be what? Minus 90 degree line. So this is minus 180 degree line. This is minus 270 degree line, right? We have a magnitude as infinity and phase as minus 90 degree. Means somewhere I have the magnitude infinity here, means larger value at minus 90 degree. Means this is my first plot, means where omega value is what? 0, right? If I go on increase the omega value, say 0.35, what is the magnitude I am getting here? It is 2.2. What is the angle? Minus 144. So minus 144 angle will come somewhere around, say in the third quadrant, assuming that here. What is the magnitude I am having here? 2.2. See, up to this, on this circle the magnitude is 1. Why? Because unity circle having the magnitude is what? 1. 2.2 magnitude means it will come outside the graph, means outside this unit circle, somewhere here I will get, right? Similarly, so this is what the minus 144 angle means. This is the minus 140, what is that, 144 degrees angle, right? Similarly, next value, here in this case omega will be how much, 0.35, right? So if I take the next one, 0.4, so 0.4, what is the value of magnitude, 1.8, angle is minus 150, somewhere minus 150 will get here, means this will be the minus 150 degrees. Magnitude is how much, 1.8, means again it is outside the circle, right, somewhere here, right? Angle I have shown, it is a minus 150. Similarly, you go on increase the value of this omega. So I will plot this one. For omega equal to 0.58, it will cut the unit circle, means magnitude is what, 1. At what angle it is, minus 168. Somewhere here, minus 168. So this is somewhere at angle minus 168 degrees. So I will get, or cuts the unity circle. This is the unity circle. This is what the omega Gc, means gain crossover frequency, right? Again, if I increase the value of omega, see here at this point, at omega equal to 0.71, so I am getting the magnitude as 0.7 and angle is what, minus 180 degree. Somewhere here 0.7 means inside the circle magnitude. This width will be what, how much, 0.7, and angle is minus 180 degrees here, right? If I further increase the value of omega, so if I increase the omega equal to infinity, so you get the magnitude as 0, angle is minus 270. Minus 270 is here. So therefore, the end point of the polar plot will be here. Means it will start like this, polar plot. Then it will terminate in this way. So I should show with the arrow mark how exactly it is moving. After plotting this graph, the main thing here is you need to denote omega Gc. Omega Gc is how much? I mentioned here 0.58. So that is 0.58 radians per second. What is omega Pc here? Omega Pc is how much? That is, from the table it is 0.71. So this angle is minus 168. This value is what? 0.7. So these four values if we have, we can easily find out gain margin as well as phase margin. Let us look how exactly we need to calculate gain margin as well as phase margin using the graphical representation. Now we have the formula to find gain margin is that gain margin is equal to 20 log of 1 by length of OQ. Here OQ means O is the center, Q is this point. Length of OQ is how much? 0.7. So that will be the gain margin. 20 log of 1 by 0.7. If I substitute this value, I will get the answer as plus 3.09 decibels. This is the GM value. Similarly, if I want to calculate PM, PM is equal to 180 degree plus 5. Means which 5 value you need to consider? The omega value at which it crosses the unity circle. So what is the value it is? Minus 168. That we need to substitute here. 180 degree plus minus 168. How much you will get? It's on 12 degrees. This is PM. You can observe here both GM and PM are positive. Both PM and GM are positive. The system is what? System is stable. If GM and PM are negative, then system will be what? Unstable. In this case, for the given G of S value, the system is stable. One more point also we can say, so if the condition is that omega Gc is less than omega Pc, so in this case also system will be stable. So in detail of this, in the summarization I shared in the notes, you can refer the things. We'll stop it here now.